Hello everybody. This is the seventh and most probably the last video of this course. Maybe in future we can make another course on color image processing or an advanced course. Today we want to talk about morphological filters. So if you had a look at the previous videos, you have some information about how to make a filter and how to apply it on your image. So first we talked about the spatial filters, and after that we used those filters in frequency domain. However, in morphology filtering, it is a bit different, and how you apply your mask is a bit different, because it is not like spatial filters, and it works based on another concept. However, today I'm not going to explain the process, as it needs a complete video perhaps. However, just I would like to shortly, as a reminder, tell you about how to apply a more I'm sorry logical filter. So how to apply a morphological filter. If we can just make a quick example here. For example, we have a small image, 4 by 4. Okay, and if we consider it as the basic example, like a binary image. So if you have an object, for example here, I put 0 for background to be black, and I put 1 for the object that is white. Okay, so you see that in our image we have an area like this that is white. Okay, and for example, you believe that this is not one object, this is two objects, but it is connected with this pixel. So if you want to count, for example, objects in your image, you will count wrongly. Instead of two objects, you will say that I have one object. In this case, with a morphology filter, you are going to detach these two objects. Okay, and how it works by eroding the white area. Okay, this erosion helps you to remove that one extra pixel and detach the two objects, and finally the counting will be correct. In this case, if you detach them, you will have, for example, 1 and 1 here, and 1, 1, 1 here. So we will have a 0 here. In this case, if you count the objects in your image, your algorithm will recognize two objects. Okay, this is what we want to do. So for doing this, you need again a sorry. So I come here, new. You need also a kernel, okay, a mask, and this mask can have different shapes, okay. For example, if I make just example like this, okay, sorry, this is just 3 pixels, okay, 1 1 1, okay. Or for example, it can have another shape, all right, it can be just linear like this, 1 1 1 1, or even like this, okay, just as a reminder, all right. And in fact, you can make your own kernel with the shape that you want to have the effect that you want on your image, all right. For example, you know that this example affects your shapes in your image horizontally, okay, because it is like a line. So if you apply erosion, it reduces the volume horizontally, or if you apply for example dilation, so it makes them longer horizontally, it makes the objects longer horizontally, all right. And again, I remind you that we don't have here zeros, okay, because here in morphology filters we applied them with logical operators, all right. So operators were, for example, and, okay, or okay, so I can write them, all right, and, or like this. So with these operators we apply our mask on the image, and the result is treating the shapes in your image based on the shape and figure, okay, the forms. This is why they call them morphological filters. And the filter that you have, the mask that you have, you call it structuring element. Structuring element. Okay. All right, like this. So I think, yeah, based on just this short introduction, we can open MATLAB and take a look at the documentation. For example, here I will search for strel, okay, like structuring element, all right. And we take a look at the documentation that we have. So you see that here it shows you an example, and it has this nice explanation about how to create it, how to use your structuring element. Okay, so we have this function strel, and we define our structuring element, and you have these examples. It can be with different shapes, diamond, disc, and different examples, plus the ones that you yourself can make. Okay, for example, if I bring just this one and execute here, okay, so I put 8, for example, you see that this SE has been saved in this structuring element. If you open it, you will have the neighborhood and the dimensionality. So we can open them, you see here, and dimensionality like this. Or this one, so I bring it here, diamond and R. So for R I put, for example, 5, and if I open it and show you the neighborhood, you see this is the diamond, all right, that you have. All right, so this for the structure element, and now you need to apply it, and MATLAB gives you different functions. The most important functions are erosion and dilation, that you apply them with im erode and im dilate. Okay, so let's check im erode. Here you go, you see erode image. Okay, you need the image and you need the structuring element, and it will apply your filter on the image. All right, let's have an example. So I open an edit. So I again can start with CLC and clear. Let me just read an image. I say, for example, eggs erode dot, I think, JPG. Okay, this is the image that I have prepared for you. So I say SE equal to strel, or you can call it a strel, and the type. Okay, for example, I choose a disk, and the size, for example, I say 3 and 6 for R and N. Okay, so I1 equal to im erode your image I and your structuring element. All right, and just we can show the results. All right, im show I1. In fact, here you can show both of them. So I say subplot 2, 2, 1, and 1 to be the original image. Okay, let me paste it again. And 2, 1, and 2. The second image be the filtered image. So we can run this and just I name it test erosion. Okay, it's running. We can come here to see if we have an error or not. All right. So on the top you have the original image, and I can zoom here, to show you that, for example, you have some dots and some unwanted objects in your image. Okay. Plus we have the text that we want to make it clear to, for example, read it by an algorithm. But you see that there are problems. Some of the letters are connected with some unwanted objects. Okay, so how to clean it? And oh my god, okay, I think if I choose it all, it will become okay. So we wanted to erode the objects. Okay, and if I show it a little bigger, I think it can be more interesting. All right, so you see that, for example, you have this text and you need a robot, you need an algorithm to read it, to detect the letters for you and read the sentence for you. Okay, for example, if this is the plaque of a car, okay, and you have recorded the plaque and you want to find the car, so you need to identify each letter. In this case, if they are connected, okay, if the plaque is not clean, or because of any errors, okay, or the weather, they are connected to each other. So how we can remove those objects? Okay, for example, here, clean this part, and this area, clean it to disconnect these two letters, okay, and recognize them. So in this case, you see that by just this morphological filter, you could do this job very well, and you have cleaned it up, and you have your object and the letters that are easily detected. So this was for erosion, okay, and we can not to just in fact modify this, I can just come down, all right, and by Control R I will make it comment. All right, and for dilate, let's read another image. For example, I read leaf.jpg, okay, and in fact I can show it to you. So I say show. All right, so you have this image, all right, and you are going to detect this leaf, okay, and remove the background, and for example count the area. So what we should do, so first of all I can just change it to a gray image, okay, for easier processing. I say I, so now I has become a gray image in this step. After this, by thresholding, for example TR, okay, I for example smaller than 150, okay, this value is the value that I have tried it before, and it works. So this is not just something to choose, okay, so you try it before, and the value that is good for your image you choose. All right, so I execute them, and here for example I say TR, so just I execute this part to show you the result. This is the result. All right, after thresholding I have this image of the leaf, but and in fact it is nice because the background has been removed very well. But if you want to count the pixels or the area or any other thing, you will have problems, because you see that you have holes inside, okay, and in the edges also you have a very rough edge, okay. So what to do, we say that we can use a morphological filter to dilate, to grow the area, okay. In this case you can remove those holes and you can fix the edges. All right, so let's define now our structuring element. I think just we can try with this disk, and I1 now here will be in dilate. All right, so we show this image and we show I1. So now we can execute. I think here I made a mistake. I should put after thresholding here. So now you see the result, that it is pretty interesting, and you don't have those holes, and they have been fixed, and you have the edges that are pretty smooth and fixed. Okay, so this also was a nice example for dilation. However, normally um, we use a combination of dilation and erosion, because we say that, for example, in this example, yes, we fixed this problem here. We don't have holes. We fixed the edges. Yes, we don't have those rough edges. But the problem is that now the area is a bit bigger than the original image. All right. In this case, what to do? So, for example, we say that we apply once dilation and after that an erosion. In this case, you will fix the holes, and by applying an erosion, you will fix the area to the original area. And you see, for example, in this part, how it is thicker than this. Okay, so this is called, for example, duck in close. I will show you. You come here, you see that enclose is a morphologically close image. So you need the image and you need the structuring element, and it performs what? Here it says is a dilation followed by an erosion. All right, a dilation followed by an erosion. So let's make an example. Let's go to our edit. Okay, so just I make this comment also for you not to touch it. I can just copy it and modify it here. So by Control T you can uncomment it. So let me read an image. Eggs im close.jpg. Okay, so let me show you the image to know the problem. All right, so I didn't read it. I need to read and show. So I think im cl it should be maybe I am mistaken for the name, so however yes, this is the one that we need to have for enclose, because the problem is here that you have these areas now that are like a line or a curve inside of the letter. Okay, and I don't know, so I come here, so I choose for example this area. All right, you see that we have some broken parts. Okay, for example this area that is broken, so you will detect it as two objects. All right, so we need to close it. All right, but we said that it applies an erosion. You know why? Because after applying dilation, it becomes bigger. All of these get bigger and maybe get touched, get connected here. So you need another erosion. Okay, so this is enclosed that applies an erosion after also. So this is the image that we have. We need a structuring element. Okay, that we used a disk 3 and 6. Let's use it. You can try other elements also, and just in fact you need to play with different kinds of structuring elements to find the best one for your application. However, just because of the educational purpose, just I use this to have a good result to show you. So here I come and I say enclose I and SE, and I'm going to show I, and I'm going to show after closing. All right, so I execute. Let's see this. You see that mostly the problems have been solved. These objects are still there. I think we could just make this a bit stronger. If I use 8, for example, maybe it will be okay. Yes, I think. So, or even I can change the R a little bit. So now it is much better. Okay, and you see that those letters are completely fixed, and the letters are not bigger than original. Okay, and you see that the final volume is the same as the original, and they are not connected. Okay, and this is good thing about imclose. All right, the next one is open, that I leave it for you to practice with it. In fact, here that you see that we couldn't remove these objects, you could use another function that is for removing objects smaller than a size. Okay, so just I could use, for example, y equal to bw area open, which image is image I1. Okay, after processing, oh sorry, I1, and for example we say 20 pixels. If they are smaller than 20 pixels, we say that remove it. Okay, it is an unwanted object. Okay, so let's see why. In this case, we execute. Still they are there, and the result's not good. So I think I think I made this much more bigger, so I reduced this to 8, and this one I can put it 50. Okay, so if I don't, if I apply this, in fact on I, So I think I made a mistake here. So it should be I1 here. Yes, I1. And if we apply this, no. So here I think just we need to binarize in binarize I and execute. So yes, it works. And so I need to just make this a little bigger, or this one. I could just make it 5. All right, in this case, yeah, that will be thinner and it will remove them. So or 60, or just a little bigger. I put 100. Yeah, 100. It removes them perfectly. So now it is good, and this function also is amazing if you can use it. So I hope that you liked the video. I hope that you learned some techniques that can be helpful for your image processing and your projects. If you liked the video, don't forget to like and subscribe and propose it to your friends. Thank you very much, and see you soon.